Hello guys, what's poppin' y'all? Today we are solving Leetcodde problem number 3637 Trionic array. First, we'll understand the pattern visually and then we can solve the problem in O of n solution. So we are given an array nums. Our task is to return true if the array is trionic, otherwise we return false. A trionic array has 3 consecutive segments. See, strictly increasing, strictly decreasing, strictly increasing again. And all the 3 segments must have at least one element. A very important observation here is any trionic array has exactly one peak and one valley. But let us not confuse this with the minimum or the maximum value in the array. The peak and valley depend on order and not value. Let's visualize this with this particular example. Let me finish drawing the graph. So now when we try to draw the graph of the given array, we can clearly see that it follows the trionic array pattern because it is strictly increasing at first, then strictly decreasing again, and then finally strictly increasing again. So we start from index 1 and move right while the array is increasing. The moment this breaks, we have found our peak. Then we continue while the array is decreasing. While this breaks, we find our valley. Finally, the array must be strictly increasing again. Now let's look at the code for this problem. So the idea is very simple. One pass from the left to right and track 3 segments using a pointer, validate peak, valley and array boundaries. So we start with a I pointer and declare it as 1. We move through the array. First the increasing loop, that is what we are giving in the first while loop. So if that is the case, that is if the first loop is strictly increasing, we increment the I pointer by 1. That is what is happening here. Now we are defining an if statement to make sure the peak is not at index 0. So that is what if I is equal to 1, we return false, and then we define a new variable peak and assign it to the previous value. Then we check for the decreasing loop, which we can use the same code, but we can just change the operator, and then if it is strictly decreasing, we increase the I pointer again by 1, or how many ever indices that is decreasing, and then we are checking that the valley is not same as the peak, and we define a new variable valley. Valley and then for the increasing loop again same as the previous logic, and then if the last segment has length greater than 1, or if it is not valley, we return, if it is valley we return false, else if we consume the entire array and if all checks pass, we return true. Now this code will run in O of n time complexity and O of 1 space complexity. So when we submit it, you can clearly see it is running in the most optimal solution. So that's all for today. Thank you for watching. See you on the next one. Bye bye.